Hi, Assalamualaikum. My name is IZZAH binti Muhammad Rosmi from Group 8.
Hi, my name is Muhammad ARIQUE bin Ismail and my student ID is 2019896704.
Hi, Assalamualaikum. My name is AQILAH binti SHAMSUDDin.
Hi, Assalamualaikum. My name is ATHIRAH binti ARIFIN.
Hello, my name is SAFINA binti HARMIZAL.
Gas chromatography is a technique for separating components depending on their volatilities based on difference of boiling point. Second, in gas chromatography, the components of a vaporized sample are separated as a result of being partitioned between a mobile gas phase and a liquid or solid stationary phase held in a column. The research developed a method for analyzing vanillin and ethyl vanillin in milk powder using auto headspace, solid space microextraction (SPME), and gas chromatography, mass spectrometry (GCMS). 4. Due to its vanilla scent and strong milky flavor, vanillin and ethyl vanillin are commonly applied as a food flavor enhancers. Vanillin 3-methoxyl 4-hydroxyl benzaldehyde and vanillin 3-ethoxyl 4-hydroxyl benzaldehyde are flavoring additives used in the food industry. The maximum usage of vanillin, ethyl vanillin, and vanilla extract in formula for infant of 6 months and children 100 ml mg, volume ready to use. Instant food and the prescribed amount according to processing demand, respectively. The maximum of vanillin allowed in newborn supplementary carrier food is 7 mg per 100 gram instant meal. The methods for detecting vanillin and ethyl vanillin in milk powder. Extracts that have been published in the literature so far. Lastly, this research created a promising method for sampling complicated mixtures that allow for direct extraction and concentration of analytes from the original matrix without the need for time-consuming intermediate process. The analytic method for determination of vanillin and ethyl vanillin content in milk powder developed in this study has seen practical value and application potential.
Hi, I will explain about the methodology. Sample preparation. About 1.5 kilograms of vanilla samples from camelling were cured by first, scalding in hot water for 30 seconds, that's 1. Second, drying in the oven at 60 Celsius for 48 hours, that's 2. Third, drying in the sun for 20 days and 2 until 3 hours every day, that's 3. Next, cured vanilla was fermented and dried in the wind. Cured vanilla was stored minimum for 2 months. Estimate 10 grams of the whole cured vanillas. Y1 was weighted for the succulation extraction Z1 and 5 grams for percolation Z2. Lastly, the 2.5 cm of cut cured vanilla Y2, about 10 grams for the succulation extraction Z1 and 5 grams for the percolation Z2 were weighed. Now we go to the extraction. Firstly, the cured vanilla of pre-extraction Z1 was extracted in the succulate extraction with 200 ml of the 99.9% ethanol for 16 hours. Next, the flask of the extraction apparatus was rinsed with small amount of 99.9% ethanol. After that, the washings was poured into the volumetric flask. The cured vanilla of pre-extraction Z2 was extracted in the Erlenmeyer. Then the Z2 was submerged about 35 ml of the 99.9% ethanol in Erlenmeyer 100 ml for 1 night. Then it was transferred into a 100 ml volumetric flask through paper filter. Filter paper was rinsed with 5 ml of the 99.9% ethanol and this paper filter was stored for use at second filtering. Lastly, the step was submerged were repeated again. High Performance Liquid Chromatography (HPLC), UV spectrophotometric and preparation of standard solutions. Firstly, the vanillin was separated on a reverse phase C-actin column using methanol acidified water 10 plus 90 and were detected at 280 nanometer. Standard solutions containing 0.5, 1.0, 2.0, 3.0 and 4.0 ppm of each standard were prepared in 99.9% ethanol for HPLC. The solution was stored at -2 Celsius until required for analysis. Lastly, standard solution for spectrometric containing 1.0, 2.0, 3.0, 4.0 and 5.0 ppm of each standard were prepared in 99.9% ethanol. Now I will explain about methodology. First of all, we go to the sample preparation. 1 gram of milk powder and 2 gram of natrium chloride were mixed with 5 ml of deionized water in a 20 ml headspace bottle. The solution was mixed using the MS3 turbine mixer for 3 minutes. For standard preparation, the vanillin and ethyl vanillin standard stock solution 500 mg per liter was prepared. 0.5 of the standard solution was dissolved in acetonitrile. 10 ml standard solution was diluted with acetonitrile and made the 100 ml. A series of metric mixture standard working solution were made by progressively diluting the solution with a blank malt powder mix. Lastly, the standard curve were plotted with peak area versus analyte concentration after measurement under instrument working condition.
In this analysis, I will explain about vanillin in white chocolate by gas chromatography. For quantitative analysis, 3 countries were chosen for the origin of vanilla to find vanillin characteristic in white chocolate, which are Madagascar, Indonesia, and Papua New Guinea. For the qualitative analysis, the temporal dominance of sensation was tested on white chocolate with 3 vanillas. The major outputs of this analysis are presented on the TDS band plots using the gas chromatography. First quantitative descriptive analysis was performed on vanilla extract, followed by QD on chocolate containing various vanilla extract. They were carried out by 2 separate panels aligned VIC methodology and comprised sensory specialists from the flavor house and the chocolate business. The flavor profiling of 3 white chocolate samples show high flavor such as sweetness and powdered vanilla. However, there are substantial difference in milk powder, almond and aniseed notes amongst the 3 vanilla sources in white chocolate, P less than 0.05. The Indonesian sample detected intense milk powder, whereas the PNG Papua New Guinea sample detected greater levels of almond and aniseed overtones. Thus, both QDA with trim panels and GCMSO studies reveal a strong link between the sensory qualities of 3 distinct origins of pure vanilla extracts and their sensory features in white chocolate. After analyzing the GCMSO data of the vanilla extract, vanillin and guaiaco were shown to have the highest odor intensity across all 3 sources. Both scent molecules are phenolic in nature. Guaiaco and vanillin are important fragrance components found in all 3 vanilla origins, Madagascar, Indonesia and Papua New Guinea. From the result, white chocolate with PNG vanilla has a very strong Rami note flavor at the beginning of the TDS, accompanied by vanilla notes. A peak of caramel flavor was not in the middle of the study. By the end of the TDS, this sample was perceived to have a slightly milky and strongly creamy flavor. At the beginning of the TDS, the white chocolate with Madagascar vanilla was perceived to have a strong vanilla flavor, which continued till the end of the sensory study. TDS analysis confirmed that sensory perception is highly influenced by the cocoa content. The more cocoa solid in chocolate, the lower vanilla perception is expected, especially with untrained consumers. This means that for white chocolate, The vanilla origin is easier to detect, even by untrained pupil, and it is riskier to chain vanilla.
Hello, so for this part, discussion and result, I will explain about vanillin in vanilla using high performance liquid chromatography. There are two results, which is in table 1 and table 2. In table 1, the linear regression equation and correlation coefficient of the vanillin standard as determined by the HPLC technique and the ISO spectrophotometric assay method. There are intercept A, slope B, correlation coefficient R. As we can see, intercept A for HPLC spectrophotometric is 188091 -00029. In slope B, 20666 15 01527, and correlation coefficient is 0997 0999. Next, the result for table 2. Vanillin content percentage W/W from 12 treatment of vanilla samples determined by the HPLC technique and ISO spectrophotometric assay method. Notes are provided, which is X1 is scalding in hot water, X2 drying in the oven, X3 drying in the sun, Y1 the whole cure vanilla, Y2 the cut cure vanilla, Z1 is solidification, Z2 is percolation. Okay, so for discussion, table 1 shows the linear regression equations and correlation coefficients of the peak area measurement for vanillin standard in HPLC technique and of the adsorbents in the ISO spectrophotometric assay method. Linear relations were observed for vanillin standard between 0 and 4 ppm with correlation coefficient of 0.997 at HPLC and between 0 and 5 ppm with correlation coefficient of 0.999 at UV spectrophotometric method. Table 2 shows the amount percentage W/W of vanillin for 12 samples determined by the HPLC technique and the ISO spectrophotometric assay method. Data show that for the 12 vanilla sample analyzed, the spectrophotometric assay consistently yield higher values than the HPLC technique. The possible explanation for this, in the spectrophotometric assay method, vanillin is not pure mixed with another substance and absorbed at the same wavelength area. This will cause high absorption. Although HPLC uses detector UV, but the sample goes through C18 column and is separated before it comes to detector cells. This causes only vanillin which is detected, and this also indicates relative smaller analytical results. However, the accuracy of this method is much better. The use of UV spectrophotometry can be more accurate if a sample is separated firstly, such as using spatial chromatography column. This way will obtain the same result with HPLC method with standard deviation less than 1%. These present data are in agreement with previous data reported by Taylor that the amount of vanillin for 4 samples determined by ISO spectrophotometric assay yield higher than by HPLC method. So for my part, I will be talking about the conclusion. The HPLC method offers a more accurate means of determining the vanillin content of vanilla than the ISO spectrophotometric assay because by HPLC method, vanillin was separated from others. The pre-extraction treatment for cure vanilla's rise resulted in higher vanillin content because there is direct contact perfectly between vanillin component in vanilla sample and extraction solvent. And lastly, the vanillin content resulted from the extraction is higher than from the percolation extraction. This occurred because there is
continually solvent purity process in the extraction. Therefore, the density of the vanillin content in vanilla extract is high. For my part, I will be talking about the conclusion of this experiment. Differences in volatile composition and descriptive taste properties between dark chocolate and milk were observed. The relationship between aroma-active compounds and sensory perception in chocolate has been confirmed. This method has been successfully used for rapid determination of vanillin white chocolate samples. Moving on to the limitations. First, the dose of vanilla in white chocolate and milk was determined experimentally. Second, only indicative sensory preference can be concluded. Last one, sensory and non-sensory research method should be better linked through the application of similar sensory descriptors. So here are some factors affecting GC separation. First, volatility of compound, polarity of compound, flow rate of gas and column material.